Hi everyone, welcome to round 2 of the Algebra 2 midterm review. Like I mentioned in the first video, I've split the midterm review into 3 parts. The first part deals with Unit 2 on quadratic functions and complex numbers. Unit 3, which is what this video is about, focuses on polynomial functions. And then the third tutorial will focus on the exponential and log unit, which also includes sequences and series. So in this tutorial, again, we have a calculator and a non-calculator section on the midterm, and you can see that there are lots of problems that deal with polynomial functions, and most of them are non-calculator based. And if you remember with polynomial functions, this is when we're looking at end behavior, we're looking at roots and factors. So a lot of this can be done without a calculator. All right, so and again, the review guide itself is in the order of the exam, whereas this tutorial focuses on the order that we learned the content. So I'm going to start with polynomial functions, problem number 3, and we're going to skip around a little bit. Okay, so problem number 3, this is a multiple response problem, and basically that means that there can be more than one correct answer. So you're given the parent function f of x is x to the 4th, and it's transformed to become the new function 5 times the quantity x minus 2 to the 4th plus 3. And let's just go over a quick review of what those transformations are. So if I have a function f of x and I transform it, I can transform it in 3 different ways. I can multiply it. Actually, let me do this in a different color. I can multiply by a coefficient. And then I'm going to have my f of x. I can shift by subtracting a value here. And then I can also shift by adding a value here. And so we talk about A, H, and K. So A does 2 things to my graph. The sign of A will determine which direction my graph is going. So basically, if it's negative, then I know it's going to be a vertical reflection. So that's important. It's a vertical reflection. We will learn about horizontal reflections in pre-calculus, but in this course, we focus on vertical reflections. So remember that. It's a reflection up and down, not side to side. The h value is our left and right shift, and you want to remember that it's always in the opposite direction. That's that minus sign. It's basically saying take the opposite of h. That's the direction you're going, the opposite of h. And then our k value is our shift up and down. And so the h value is going to correspond to the x value of our vertex. If we're dealing with an even function, the k is going to be the y value of our vertex. Or point of inflection if we're dealing with an odd function. In this case, we're dealing with an even power function. And if you remember about long-run behavior or end behavior, the graph of x to the 4th is going to look like a parabola that increases on both ends. If I consider what g of x looks like, and let me go ahead and label this function as f of x. If I think about what g of x looks like, I know that hk is going to correspond to my vertex. So that means that the vertex of this function is going to be, remember, I'm going to take the opposite of the number inside the parentheses. So that's going to be a positive 2, 3. So my graph now is being shifted over 2 and up 3. And my a value, my leading coefficient, is 5. So my graph is not going to be reflected. It is going to continue to open up. And because it's 5, it's going to be dilated. So it's going to be thinner or less wide than my f of x function. I'm going to go ahead and label this as g of x. So for this problem, since you're going to be answering questions about different characteristics of the graph, it might help to sketch both graphs on your paper. And again, you do need to kind of remember about power functions, even and odd powers, and what they're going to look like from far away. Okay, so now which of the following statements are true? Select all that apply. Okay, so f of x is an even function. And what you might remember, or hopefully you remember, that we have even and odd functions. We also have even power functions and odd power functions. Both of these are even powered functions. But this is asking, is it an even function? An even function is a function that is symmetric about the y-axis. And so any kind of parabola that has its vertex at the origin is going to be an even function. But Another example of an even function could be an absolute value function. Another example of an even function could be a sine or a cosine function. Well, really a sine, depends on how it's shifted. But that would be another example of an even function, because if I fold the graph in half along the y-axis, it's going to land back on itself. So an even function is anything that is symmetric with respect to the y-axis. An odd function, just while we're on the topic, let's review that real fast. An odd function is something that has rotational symmetry. It's symmetric about the origin, which basically means you're going to fold it two ways. You're going to fold it along the y-axis and then fold it along the x-axis. And if it lands back on itself, then it's said to be an odd function. So an odd power function that has its point of inflection on the origin is going to be an odd function. Because if you think about folding it along the y-axis and then along the x-axis, it's going to land back on itself. Or, like I said, it's rotational symmetry around the origin. If I swing this graph 180 or 90 degrees, is that right? It'll land back on itself. Another example would be a function that looks like this. Whoops, I did it wrong. Let me try it over here. There we go. That would be an example, another example of an odd function. So if I spin it, it'll land back on itself. And if I fold it over the y and then over the x, it'll land back on itself. So as long as I'm talking about my function f of x is an even function. Remember, f of x is my green graph, and if I fold it along the y-axis, it does land back on itself. So that is true. If it said g of x is an even function, that would not be true. It is an even-powered function, but it's not an even function in general. Letter B says f and g have different end behavior. Remember, end behavior is where the arrows are pointing. And in both of these functions, the arrows are pointing up on both sides. So letter B is incorrect. That is not true. In letter C, it says that g of x is a horizontal reflection of f of x. And again, a horizontal reflection would be a reflection over the y-axis, and we have not talked about any horizontal reflection. So if you see something about a horizontal reflection, you know that that is not true. We have talked about vertical reflections only in this class, and that happens when the a value is negative. And that's not happening here. So letter C is also incorrect. Letter D, this is another way to describe end behavior. Pay very close attention to the sign of the infinity, though. This is basically saying as x approaches infinity, that is positive infinity. And this is talking about the right side of the graph. So x refers to the left and the right side. F of x, remember, is the same thing as y, and y refers to the top or the bottom part of the graph. So what we're basically saying is as the graph goes to the right, what is happening to the y values? And this is saying y is also increasing. And we're talking about my f of x function. So it is important that you pay attention to which function it's describing. In our case, both graphs are going in the same direction, so it's not that big a deal. But since it's referring to f of x, I want to make sure that I'm referring to my green graph. So this is saying in letter D, as x approaches infinity, so as we go to the right of my green graph, y is approaching positive infinity as well. And that is true. As x increases, f of x is also increasing. So that's true. It would be true for g of x as well. In letter E, it says that g of x is shifted to the left 2 units and up 3 units from f of x. So this is something that's designed to trick you, because when you look at the equation, you see that -2. And if you don't remember, whenever you have those parentheses, you've got to remember to take the opposite of the number inside. So in this case, letter E would be incorrect because g of x is actually shifted to the right 2 units and up 3. So the only correct statements here are A and D. Okay, number 6 is the next question that deals with polynomials, and 6 and 7 are very similar. It says the volume of a box is given as, and you're given an equation, And you're asked, can one of the dimensions of the box be x plus 4? Justify your answer using mathematics. Well, one of the ways you can figure it out is to divide our v of x function by x plus 4. And if x plus 4 divides evenly into v of x, then we know that it is a factor and therefore can be the length of one of the sides. So some of you in honors learned how to do long division with polynomials. But in this case, since our divisor is of the form x plus 4, we can easily identify the x-intercept of that factor, remember, and use synthetic division, which is a lot easier and a lot less time-consuming than doing the long division. So if I have a factor of x plus 4, and that's actually something that I have in question. I'm wondering, is x plus 4 actually a factor? My x-intercept then would be that x is equal to negative 4. And with synthetic division, and you may have set this up a little bit differently, teachers do it differently, I usually put the x-intercept on what I call a shelf. And then next to that number, you're going to list all of the coefficients of v of x. Now you do want to make sure that it is in standard form and that you're not missing any terms. So if you look at the terms, it goes from x to the third, x squared, x, and then we have our constant. So I'm not missing anything. If I was missing the x squared term, I need to include a 0 as my coefficient. So I'm just going to list my coefficients, 2, 3. Make sure you remember to keep that negative, the 32, and then my 15. And again, this is a non-calculator part. So be really careful with your operations here. I know some of you still struggle with integers. So the very first step when we're doing synthetic division is to bring the first number straight down. Everything below the line is going to get multiplied by negative 4, and then the product is going to go above the line, and then we add. So in this case, I'm going to go ahead and multiply negative 4 times 2. That's going to give me negative 8. And now I add 3 plus negative 8 is going to give me a negative 5. And now that the negative 5 is below the line, I'm going to again multiply. Negative 4 times negative 5 is going to give me a positive 20. And then when I add, I've got negative 32 plus 20. That's going to give me negative 12. And negative 4 times negative 12 is going to be 48. And if I add these two numbers together, I can see very clearly that it's not going to be 0, which is what I'd want it to be if x plus 4 were a factor. So let's go ahead and add. 5 plus 8 is going to give me 13. If I carry the 1, that's going to give me 63. This last number is my remainder. And since we have a remainder, x plus 4 is not a factor. And if x plus 4 isn't a factor, then it can't be the dimensions of one of the dimensions of the box. And this is what you want to write out, because it says, justify your answer using mathematics. By showing the synthetic division, you've shown the mathematics, but you still need to answer the question. So since there is a remainder, x plus 4 is not a factor of v of x, so it can't be a side. Okay? If I got 0 as my remainder, which would tell me that there was no remainder, then my answer to this question would be different. That would tell me that x plus 4 does divide evenly into v of x, and therefore it is a factor, and it is, or it could be, the length of one of the sides. All right, number 7 is very similar. Another box situation where you're given the volume, and again, it's in standard form. I'm not missing any terms. It says, suppose the given height of the box is x plus 3. What are the expressions for the length and the width of the box? So the way that this is written, I can tell that x plus 3 should divide evenly into v of x, because I should be able to determine the length and the width from here. So if I end up with a remainder, this should be an indication that I've done something wrong. So I should not get a remainder. In this case, again, I can use synthetic division because it's of the form x plus a number. If there was a coefficient x, I'd have to use long division, but there's not. So again, if x plus 3 is the factor, then my intercept is going to be x equals -3. And the way I have taught my students to do it is to put the -3 on the shelf. And again, the format doesn't really matter. And then to list all the coefficients of your volume. So 1, 5, -2, -24. Give myself a little bit of space and draw a line. And now I'll begin. I'm going to drop the 1 straight down. And now I'm going to multiply. -3 times 1 is -3. 5 plus -3 is 2. And again, I'm going to multiply. -3 times 2 is -6. When I add -2 plus -6, I get -8. And then again, I'm going to multiply. -3 times -8 gives me a positive 24. And when I add them together, I get 0, which tells me there is no remainder. And that is what I want to see. But I need to make sure that I answer the question. So I know that x plus 3 is a factor. So that means I know it's one of the dimensions, but I was told that. I was told that it's the height. So now I'm left with these 3 numbers. It's important that you understand what those 3 numbers mean. Well, think about what we started with. We started with a polynomial of degree 3. And I divided out x plus 3. So if I divide out a factor of x, I'm no longer going to have a cubic function. I'm going to have a quadratic function because I'm dividing out a power of x. So that means that my 1 here is going to be the coefficient of x squared. It's always going to be 1 degree less than what I started with because I divided out a factor of x. And this is going to be plus 2, and then what would normally come next if I write it in standard form? This would be an x, and then I have my minus 8. So right now, I know that the volume of the box can be written. I already know that x plus 3 is one of my factors. I was given that. Another factor is x squared plus 2x minus 8. And if I multiply those 2 expressions together, I'll get the volume. But I'm still not finished because I am asked to write expressions for the length and the width. What I have in my quadratic is the product of those 2 things. So I need to divide this up a little bit more. And I can do that now by factoring. This is a trinomial. And I know some teachers call it different methods, the slide divide method. I call it product sum. Essentially, we're looking for numbers that multiply to give you a -8. And I usually do this in a table. And I call it product sum. So this is my product, -8, and the sum is 2. So I'm looking for numbers that multiply to give me -8 and add to give me 2. So I know some people get stuck on this. So let's just think about all the numbers that multiply to give me -8. I could do -1 times 8. I could do 1 times -8. I could do 2 times -4. I could do -2 times +4. If I add these numbers together, I'm going to look to see which pair gives me 2. -1 plus 8 gives me 7. 1 plus -8 gives me -7. 2 plus -4 gives me -2. -2 plus 4 gives me 2. And that's what I want. So I'm going to use these 2 numbers to factor my trinomial. And remember, these are not the solutions. So when I write my factored form for my trinomial, and that's what we mean by factored form, I'm going to keep the x plus 3. That doesn't go anywhere. And I know that this minus 2 is going to correspond to a factor of x minus 2, and this positive 4 is going to correspond to x plus 4. Now I have, let's see, we were given the height, and now I have the length and the width. And it actually doesn't matter which is which. Okay, but you should end up with 3 factors overall, and that should make sense to you because if we have a polynomial of degree 3, when I factor it, I should still have 3 factors of x. Okay, the next problem we're going to look at is problem number 10, and again, this is a non-calculator question. In number 10, it says, suppose a polynomial has zeros, and this is set notation. So it basically says that x is within the set -6, 0, and 2. And what do we mean by zeros? We're talking about x-intercepts. So this means that our polynomial crosses the x-axis at -6, 0, and 2. So if these are my x-intercepts, so if x is equal to -6, 0, and 2, then the first thing I want to do is write this in factored form. So I'm going to write y equals And if I have an x-intercept at -6, that should remind you to write it as x plus 6. If I have an x-intercept at 0, that would be the same as saying x minus 0. And if I have an x-intercept at 2, that's the same as x minus 2. Now this quantity here, x minus 0, obviously it's just going to simplify to x. And some of you are able to do that right away. And a lot of times we put the x in front. And so we'd have x times x plus 6 times x minus 2. And that's what the equation would look like in factored form, or an equation. If I multiplied the whole thing by 2 or -6 or even another x, it would still have the same zeros. All right, the next bullet asks us to write the equation for the polynomial in standard form. Well, here's where we use our order of operations and we multiply the whole thing out so that we get it in standard form, which is going to correspond to the equations in the last bullet. But when we're multiplying, we don't ever multiply 3 things together at the same time. We multiply 2 things at a time. So the first thing that you might consider doing is multiplying those 2 terms together. So if I distribute my x, that's going to give me x squared, and that's going to give me 6x. I do not continue to distribute the x in the second quantity. I leave it at that. So what I have now is x squared plus 6x times x minus 2. And now I want to multiply those 2 together. And this is just 2 binomials that I'm multiplying. So I could use the FOIL method, or again, if you're more comfortable, you can use the box method. And it doesn't matter. It doesn't matter if you do your x squared plus 6x here and your x minus 2 here, or do it the other side. It doesn't really matter. But remember, we multiply to get the values within our box, and then we add them together. So x times x squared is actually going to be x to the 3rd power. X times 6x is going to be 6x squared. -2 times x squared is going to give us -2x squared, and -2 times 6x is going to give us -12x. And now I'm just going to rewrite this by adding together all my like terms. The x to the 3rd doesn't combine with anything. Whoops, let me write that as x to the 3rd. But I can add my x squares together. I have a positive 6x squared along with a -2x squared, and together that's going to give me 4x squared. And then I have a minus 12x. So that is an example of an equation in standard form that will correspond to the equation that I have in factored form. In the last bullet, it asks which of the following functions are equivalent to the one above. So in this case, I want to look first at my exponents. Let's look at the degree. If I have 3 x-intercepts, I have to have a polynomial of at least degree 3. So that eliminates this first option. It would be impossible for this polynomial to be quadratic. The next thing that I want to look at is the pattern of the signs. So notice my first term is positive, my second term is positive, and my third term is negative. So I can eliminate anything that doesn't have the same pattern. So, or an opposite pattern. So if it went negative, negative, positive, that would actually be okay. But if my signs switch, then I know, for example, letter B, where everything is positive, I can eliminate that option. In fact, if I look at example C, where everything is negative, I can also eliminate that option. So let's take a look at the last one. We've got 4x to the 3rd plus 16x squared minus 48x. And it may look very, very different than the original equation that we have. And if I look just at the coefficient in front, there's a 4 there. Well, what would happen if I multiplied this equation by 4? I would get a 4x to the 3rd, and I'm just going to distribute. This would become a 16x squared. And if I multiply 4 times -12, I'm going to get a -48x. And as long as that is the same thing as I have here in letter D, then D is equivalent. As long as I don't multiply by like another x minus 2 or x plus 3, I can multiply by a number. I can even multiply by a single, like a factor of x, because it would still correspond to an x-intercept of 0. So the correct answer here is D. Okay. Number 11 is another one that you cannot use a calculator, and this really has to do with end behavior as well. You have several equations that are written in factored form. If we look at the first one where it says f of x, notice that we've got x plus 1 times x plus 1 times x plus 1. That is equivalent to saying x plus 1, the quantity cubed. And then I've got this x minus 3. So think about where the x-intercepts will be and what the multiplicity of those roots would be. So x plus 1, the quantity cubed, tells me that I have a root at -1 and it's going to be a triple. It tells me that I have a root at 3 and it's going to be a single. The other thing you want to look at is the leading coefficient. So notice that in this function the leading coefficient is positive. Well, it's positive in h of x too. So I know that those two graphs have to be increasing to the right. If I look at my functions over here, g of x and k of x, both of those have a leading coefficient that is negative. So that's going to correspond to the graphs that are going down to the right. So I know in number 11 that f of x is either going to be a or d. Let's take a look at h of x too. Notice that when I look at h of x, it's already written in a simpler form where we have x minus 1 is already cubed. Well, this tells me that positive 1 is a triple root and -3 is a single. So you really have to remember here to change the sign when you're going from a factor to the x-intercept. And that's because these are zeros of the function. So if I have a factor of x plus 1, to find the zero of the function, I set it equal to 0 and I subtract 1 from both sides. That's why it's opposite. All right, so let's take a look at f of x. I'm looking for the graph that opens up that has a triple root at -1 and a single root at +3. That's going to correspond to letter D. Because remember, a triple root is going to change concavity. A double root changes direction and a single root passes straight through. So I know that f of x is going to be D. That means that h of x has to be A, because I've got a triple root here at +1. G of x, I know, is going to be going down. I have a single root at 3, and I have a triple root at -1. K of x is a lot like f of x in that we've got these three factors that are the same. So I can also express it as x minus 1, the quantity cubed. So basically I have -3 is a single root and +1 is a triple. So for g of x, I'm looking for a single root at +3, and that would be my single root at +3, and -1 is a triple. So that means that g of x is going to correspond to the graph of B, and k of x is going to correspond to the graph of C. All right. Number 12 is another matching one, and it's dealing with end behavior. I want you to be really careful with this problem, though. If you look at the right-hand side, where we're looking at the behavior of the graph, notice that the first statement is talking about x approaching positive infinity. So we're looking first at the right side of the graph, and then the left side of the graph. So just make sure that you're looking at the correct side of the graph for the end behavior. The first thing I would suggest you do in this problem is understand what the degree is, and then pay attention to whether or not the graph should be increasing or decreasing. And we have let me just do a quick summary of these things. So if we look at the degree, we know the degree can either be it's either going to be even or odd. And then we also have our leading coefficient. And our leading coefficient is either going to be positive or negative. So if we're dealing with an even degree that has a positive leading coefficient, it's going to look from far away, both ends are going to be increasing. If the leading coefficient is negative, then it's going to be reflected vertically, and both ends are going to be pointing down. If it's odd, that means that the ends are going in opposite directions. If my leading coefficient is positive, it means it's going to be increasing to the right. And if it's negative, it's going to be reflected and going to be decreasing to the right. And this can help you understand end behavior a little bit better. So let's take a look at the first example. I've got I'm just looking at the leading coefficient and the leading degree, or the leading term. And do make sure that your equations are in standard form when you're trying to identify the leading term. So I've got negative x to the third. My power of 3 tells me I'm dealing with an odd function, or an odd degree function, that is negative. So I know from far away this graph is going to look like this. And I'm actually just going to sketch the behavior for all of them before I start looking at the answer choices. The next one, we're looking at a leading term of 6x to the fourth. My exponent is even, and my leading coefficient is positive. So I know that both ends should be pointing up. The last two are a little different because now they're written in factored form. So count the factors of x. This factor here is cubed, so that means it counts 3 times. Then I've got 4, 5. So this is degree 5. And notice that the term in front is positive. So I'm dealing with an odd function, or an odd degree function, that is positive. So it should be increasing to the right. If I look at the last one, I've got x squared, so that gives me 2 factors of x. Here's the third and the fourth one. So I'm dealing with a degree of 4. And notice that my leading coefficient is negative. So that means my graph has ends that are both pointing down. Okay. So again, now when I look at my answer choices, letter A says that on the right, it should be going down, and on the left, it should be going up. So on the right, it's going down. And actually, why don't we just draw it? So if it's on the right going down, on the left it's going up. And so that's going to actually correspond with the very first equation. So in letter B, on the right, it's going up. And on the left, it's going down. So on the right, it's going up. On the left, it's going down. That's going to correspond to the third graph, or the third equation is going to go with B. The even end behavior is really obvious. Notice that both ends are going down. So that's going to be obviously the last one. And in this case, both ends are going up. And again, so that's really obvious. When the ends are going in the same direction, it's usually easier to tell. All right. In number 14, we are looking for the average rate of change. And in number 14, this is a problem that you are allowed to use your calculator. The average rate of change, we are essentially finding the slope between 2 points. So we're given a table that shows the age of a child and the child's height in inches over several years. So if I want to find the average rate of change in height from a child from age 2 to age 5, those are the only 2 ordered pairs I'm interested in. This one and this one. I'm going to call this point 1 and I'm going to call this point 2. And if you remember your slope formula from Algebra 1, we know that the rate of change is computed by taking the difference in the y values, y2 minus y1, over the difference of the x values. And it actually doesn't matter which equation or which point you identify as your first point and which you identify as your second point, as long as you're consistent. And that's the important thing. You don't want to switch directions. So if I want to compute my rate, remember my age is going to correspond to my x variable and my height is going to correspond to y. So when I'm doing my y values, I'm going to look at 41.73 minus 33.15 over my x values, which is going to be 5 minus 2. You can do this all in one step on your calculator, but please make sure you put parentheses around the numerator and the denominator. And this is something that you're allowed to use a calculator on. So in parentheses, I've got 41.73 minus 33.15. I'm going to close my parentheses before dividing, and again, I need to put parentheses around my numerator or my denominator, 5 minus 2, or you can just write a 3. And we get 2.86. So that means that the child is growing, obviously, and we want to make sure that we include units. Well, since my y variable is on top, I'm going to keep my y units on top. So that means that my y units are inches and my x units are in years. And so what that means is this child is growing 2.86 inches per year. All right, and that, I believe, concludes the second tutorial on polynomial functions. Stay tuned for the tutorial on exponential and log functions. That includes the sequences as well.